Hello. So now I'll be solving question number 23 from phase 1, chapter called Forces and the Laws of Motion. Let's read the question. A projectile is fired vertically from the Earth's surface. So if this is Earth, the radius is 6,400 kilometer. From here, the projectile is fired in upward direction with the 10 kilometer per second initial velocity, neglecting atmospheric retardation. So there is no retardation because of the friction due to atmosphere. How far above the surface of the Earth would it go? So at the highest point, the velocity will become zero. That's what the highest point means basically. Earth radius is given at 6,400 kilometers. Now this question is from the gravitational chapter actually. The more about this chapter you'll be learning in the gravitation chapter, but during the 9th standard also you learn about it. So I'll give you the basic idea. Now when it comes to motion of this projectile, we have to know about the potential energy. So potential energy in the Earth system, is minus of capital G small upon RE plus. That's the formula. The capital G is the gravitational constant. Capital M is the mass of the Earth. Small m is the mass of the projectile. RE is the radius of the Earth, and H is the height. In this case, when the projectile is moving up and down, there is no external agent working in this case. There is no external agent acting because Earth's resistance is given 0 and there is no friction involved. So in this case, you can say momentum, not momentum, basically mechanical energy of the whole system will be conserved. So initial mechanical energy, which is K1 plus U1, kinetic energy plus potential energy, will be equals to the final kinetic energy plus potential energy. The detail we will do in the gravitation chapter. And this thing we will be learning in the work power energy chapter. So system's initial mechanical energy will be same as the system's final mechanical energy. Now, when it comes to system's initial mechanical energy, it is a summation of kinetic plus potential. So that is equals to when we write the value of K1, that is equals to half of mass of the projectile multiplied with velocity of the projectile initially, which is given as 10 kilometer per second. So if I convert that in terms of meter per second, it will be 10 to the power 4 square. So 10 kilometer per second is 10 into 10 to the power 3 meter per second, which is 10 to the power 4 meter per second. Initial potential energy of the whole system is minus of G, mass of the Earth, mass of the projectile, divided by RE, which is 6,400, plus H. But the H is 0 here, so 6,400. It's a kilometer, so 10 to the power 3. Now, when we talk about the final kinetic energy, obviously, we are looking at the maximum height. And at the maximum height, the kinetic energy has to be 0 because particle will be coming to rest. So final kinetic energy, which is K final, will be 0. We are talking about the maximum height. And at that instant, the final potential energy will be equals to minus of capital G E small m divided by 6,400 into 10 to the power 3, which is RE plus H. Max. We are talking about the maximum height. All these four values will be putting in this equation. Conservation of macro energy equation when we put, and when we'll be solving it, the mass will cancel out. Mass from here will cancel out these masses. This whole value, capital G ME upon RE square is equals to small g, which is 10, or you can take as 9.8, and RE is given. So we'll replace the value of GM and E. GE will replace from here. And when we put all these values in this equation, we'll be getting the value for H max, maximum height, as 2.5 into 10 to the power 4 kilometers after solving. Okay. So this question, more about this question, you will be learning in the gravitation and work power energy. This is a combination of those two chapters. Okay. At this point of time, we are solving it to get the idea, a little bit idea beforehand itself. Okay. Thank you.